All right, we are down to our last section in Unit 12. This is 12.7 odds. Now, odds and probability have a relationship. When we were looking at probabilities, okay, we were looking at, so if we're looking at probabilities, we were looking at favorable outcomes over total outcomes. Okay, odds are a little bit different. Okay, this time instead of comparing favorable outcomes to total outcomes, we're comparing favorable outcomes to unfavorable outcomes, or in the event that we're talking about odds against, okay, we're talking about unfavorable outcomes, we're comparing those to favorable outcomes. So this time we're not comparing it to a total, we're comparing it to the opposite happening. Okay, so you'll notice here the equations here, if that's helpful for you. Odds in favor is number of favorable outcomes compared to number of unfavorable outcomes. Odds against is number of unfavorable outcomes compared to favorable outcomes. So again, neither of these numbers here are the total number of options, like we were working with probabilities. Okay, odds is strictly comparing things that I want as a ratio over things that I don't want. Okay, or if you're looking at odds against, it's the reverse, right? The odds of, or the ratio of unfavorable outcomes compared to favorable outcomes. All right, I think it'll be helpful if we look at some examples here. Study indicates that out of every 60 telephone calls, 42 are answered, 6 result in busy signals, and 12 result in no answer. What are the odds in favor of someone answering? Okay, so what we want to do here is look at the number of times that someone did answer. Okay, so you'll notice here that that number is 42. Okay, so that's going to be on the top of my fraction, but we're not comparing it to the total number of phone calls. If we were looking at probabilities, we would look at the total number of phone calls. This would be 42 out of 60. Okay, but we're not looking at probabilities here, we're looking at odds. So what we want to compare it to is the number of times that people didn't answer. So the top number is the number of times that people did answer. The bottom is going to be the number of times that people didn't answer. So if I count all the times that people didn't answer, that'd be 6 and 12, which would be 18. So 42 times that someone did, 18 times that someone didn't. And we want to reduce that as a fraction, 21 over 9. I can divide both of those by 3, 7 over 3. Okay, now if you can write this as a fraction, okay, you can also write this as a ratio. So something like this would also be appropriate. Okay, 7 divided by 3, or just 7 to 3. Letter B, what are the odds against someone answering? All right, so if we want the odds against someone answering, we talk about the unfavorable outcomes. Okay, there are 18 unfavorable outcomes, right? 18 times that someone didn't answer, and 42 times that someone did. So we're not comparing it to the total, we're comparing it to the opposite. Okay, so 42 on the bottom, so 18 out of 42, you can reduce that as a fraction again. So again, that's just going to be the opposite, right? 9 over 21, which would be the same thing as 3 over 7, or 3 to 7. All right. All right, what are the odds in favor of a busy signal? Okay, so this time we're looking at 6 result in busy signal, so that'd be 6 on top. Okay, how many times did someone not get a busy signal? That would be 42 were answered and 12 resulted in no answer. So 42 times that you got a busy signal, and 54 times that you did not get a busy signal. So that'd be 6 compared to 54. Okay, you can reduce that. I can divide both of those by 9, which would be 1, or excuse me, divide both of those by 6 would be 1 over 9, or 1 to 9, okay, which is letter B. Okay, gumball machine has 6 red, 12 orange, 9 yellow, 1 green, 8 blue. What are the odds in favor of randomly selecting an orange gumball? Okay, so again, we're comparing the number of times we get an orange gumball to the times that we don't get an orange gumball. Okay, so look at how many times we get an orange gumball. Okay, 12 orange, okay, which goes on the top of the fraction. Okay, we can count up the number of times we don't get an orange gumball, which would be 6 plus 9 is 15, plus 1 is 16, plus 8 is 24. So 24 times that I don't get an orange gumball. Okay, so I get 12 out of 24, which would be 1 divided by 2, okay, or if you want to write it as 1 to 2, that's fine too. Okay, what are the odds against randomly selecting a red gumball? Okay, so we got to think about the times that we don't get a red gumball. So there were a total here of, 36 total, right? So how many times did we get a red gumball? We got a red gumball 6 times, which means that we didn't get a red gumball 30 times. Okay, so the odds against would be 30. Okay, over the number of times I did get a red gumball, which is 6. So again, we're not comparing it out of a total here. We're comparing it to a number of times we don't get a red gumball to the times that we do get a red gumball. 30 times I don't, 6 times that I do. Okay, so what we'll do there is we'll divide both of those. I think we can divide both of those by 6. So that'd be 5 to 1. Okay, or 5 to 1. All right, bag contains 7 blue, 5 green, 9 yellow, 1 red. Marble is drawn at random from a bag and then replaced. Okay, so that's important because we're going to be looking at replacing this. Again, that's what's known as, we can think about our dependent versus independent events. Okay, if it's independent, okay, it's not affecting it, okay, because it is being replaced, this would be independent. Okay, find the odds in favor of drawing a yellow marble. All right, so we want a yellow marble. Okay, yellow marble would be 9. Okay, let's think about the times that we don't get a yellow marble. Okay, so it'd be 5 and 7 and 1. 5 and, so that'd be 7 and 5, that's 12, and 1, that's 13. Okay, so I think that's going to be 9 to 13. Okay, 9 times I get a yellow marble, 13 times I don't get a yellow marble. Okay, we can look to reduce that, but I don't think 9 over 13 reduces. So we'll just circle that, and that'll be it. You could write this as write that as a ratio as well. Okay, and that's it. So 9 times I do get a yellow marble, 13 times I don't get a yellow marble. Again, we're replacing that marble every single time, so it's not going to change on successive draws. According to a meteorologist, there is a 40% chance that it will rain today. What are the odds against rain? Okay, so this requires us to know a couple of things. Okay, 40% chance that it will rain, okay, means that there are a 60% chance that it won't. Okay, so if it's 40% that it will, it would be 60% that it won't. Okay, so the odds here are against rain. So we said that it's a 60% chance that it won't rain compared to a 40% chance that it will rain. Okay, again, we're not comparing 60 out of 100. Okay, that would be a probability. We're looking at odds here. So we're comparing the odds that it won't rain to the odds that it will rain. So 60 out of 4, I can divide those by 10 and get 6 out of 4, which reduces to 3 out of 2, or 3 to 2. Okay, and I look to see which letter that corresponds to be, which is going to be letter C. Okay, probability of an event happening is 7 to 10. What are the odds in favor of the same event happening? Okay, so this is where we got to be careful here because they're giving us probabilities, which means we have to think about using the probabilities to help figure out odds. Okay, so the probability of an event is 7 out of 10. Okay, so if you think about this here, there's 10 total options. 7 of them are favorable, which means that 3 of them are not favorable. So probability of 7 out of 10 would mean that 7 is for and 3 is against, giving me a total of 10. Okay, so if the probability was 7 out of 10, that means the probability was 7 for, 3 against, which is going to help me write the odds, right? So the odds in favor of that happening would be 7, instead of 7 out of 10, I've got 7 for, and we're comparing it to the against, or the opposite. Okay, so it would be 7 over 3, not 7 out of 10, okay, which is equal to 7 to 3. Okay, that does not reduce, so we can leave it like that. Okay, All right, so the probability, next problem, the probability of an event happening is 5 out of 14. What are the odds against that same event happening? Okay, so again, we can do the same thing. If the probability of the event for the event happening, which means 5 times it was 4, and if the probability was 5 out of 14, we can do some simple math there. That means 9 times it was against. Okay, 5 out of 14 probability means 5, 4, and 9 against. Okay, what are the odds? So now I can compare the odds against to the odds for, okay, which means 9 goes on top, 5 goes on the bottom. Because I want the odds against, that means the 9 against, the 9, which is against, goes on top, and the 5, 4 goes on the bottom. Okay, and that's equal to 9, 5 as a ratio, and that'll be it. Okay. All right, we got a last section here, okay, where we're kind of mixing and matching the probabilities with odds. We got to be careful about knowing whether it's talking about probabilities or knowing whether it's talking about odds. What is the probability of spinning a multiple of 4? All right, so let's think about probabilities here, which means we're comparing it to a total. Okay, so how many multiples of 4 do we see on here? Okay, so that would be a total of, I think 4 would be a multiple of 4 and 8 would be a multiple of 4. So that would be a total of 2 things that are multiples of 4, 2 options for multiples of 4. We're doing probability, so this means we're comparing it to a total. So I count the number of spots here, which is going to be 8. Okay, so 2 out of 8 is going to be 1 out of 4, which will be letter B. Okay, what are the odds against spinning a number less than 4? All right, so let's take a look at this here. We got to think about the options of a number. Okay, so for a number less than 4, okay, would be 1, 2, and 3. Okay, against would be everything else, 4, 5, 6, 7, and 8. Okay, so if I want the odds against spinning a number less than 4, okay, we look at how many options there are spinning against, okay, which is 5 options. Okay, now we're not comparing it to a total, we're looking at odds here, so we're comparing it to against to 4, okay, which there are 5 options for against. There are 3 options for, okay, so that would be 5 to 3 or 5 to 3, which would be letter B. All right, number 3, what are the odds in favor of spinning a number greater than 2? All right, so again, we could make our list of numbers for and against. Okay, we're doing odds here, which means we're comparing for to against. Okay, so we want odds in favor. Okay, so options of spinning a number greater than 2 in the for column would be 3 and higher. So 3, 4, 5, 6, 7, 8. Against spinning a number greater than 2, options would be 1 and 2. Okay, I want options in favor here. Okay, so what we're going to be doing here is doing 6 options for, that'd be 3 and higher. 6 options for. It's odds, so we're comparing it to against, not a total. So 2 options against, okay, which means that would reduce to 3 over 1, which reduces to 3 to 1 as a ratio, which would be letter A. Okay, those are the easy ones. We got 2 more here that we're going to have to do some combinations here, I think. Or I should say some ors and ands, I think, which is from last section, or the last 2 sections. What is the probability of spinning an even number or a prime number? All right, so we know that we're doing compound probabilities here, compound or probabilities, which means I add the probability of an even, so I can look at the options for an even, and then do prime. And remember that when we do those, we are finding the individual probabilities, we add them together, and then we subtract out the ones that are duplicates or multiple, or I don't count them twice. Okay, so even numbers here would be 2, 4, 6, and 8. Prime numbers would be 2, 3, 5, 7. Okay, so the probability for an even number would be 4 options out of 8. Again, we're looking at probabilities, so it's favorable over total. Okay, plus the probability that it's prime. There are also 4 primes, so 4 out of 8 plus 4 out of 8. But now you get to subtract the ones that are in both lists. So let's look at the ones that are in both lists. 2 is in both lists. Okay, and I think that's going to be it. 2 is the only number that shows up twice. So one of the options shows up twice. So 1 out of 8, because I have 1 duplicate there. All right, so 4 out of 8 plus 4 out of 8 would be 8 out of 8, minus 1 out of 8, which would be 7 out of 8. Okay, so 7 of those options are either even or prime. Okay, so in fact, the only thing that wouldn't work there would be a 1, right? Okay, the only number between 1 and 8 that is not even or prime is the number 1. All right, last one here. What is the probability of spinning an even number and then a prime number? All right, so this is going back to what we did in compound and probability, which just means we're multiplying the 2 probabilities together. Okay, this is going to be an independent event because the probability of spinning the first time does not impact the probability of spinning a second time. All right, so what we can do is just think about spinning an even number. Okay, so again, this is probabilities. So we're doing favorable over total. Okay, so in this case, if I want an even number, okay, the options there are 2, 4, 6, 8. Then a prime number. Okay, and actually this is the same list as we had last time. So 2, 3, 5, 7. Okay, and then we can do, all right, so the even options would be 4 out of 8 multiplied by the prime options, which would also be 4 out of 8. Remember, compound and probabilities just means I multiply the probability of the first event happening times the probability of the second event happening. So what I can do there is just multiply those two together. That gives me 16 out of 64, which reduces, I can divide both of those by 16, which gives me 1 out of 4, which is letter B. And actually I didn't circle the answer for number 4, so I should go back and do that. That's letter D. Okay, 7/8 was number 4. 1/4 was letter B. All right, and that's just review. Those two problems were just review for 4 and 5. The big thing here is just to remember, kind of going back to what we did at the beginning, is to just understand whether we're looking at probabilities or odds. Probabilities are comparing something favorable to the total number of options. Odds are comparing favorable options to unfavorable options, or unfavorable options to favorable options, depending on whether we're looking at for or against, right? In favor or against. So we're just comparing. So just be careful about that. It's not necessarily something that's super complicated, but just make sure that you're clear on whether you're doing odds or probabilities when you're looking at each of those individual problems. All right. Okay, so that's it for the notes, folks. Let me know if you have any questions. Otherwise, you can get going on your homework for the day. Thanks, guys. Bye.